So in this problem, we need to determine the equation of a circle such that its center lies on the line 5x plus 12y equals to 1, and the circle is also tangent to both the x and the y axis. So let's first try to understand the problem graphically. So here we have our Cartesian plane with the x and the y axis, and we have a circle with center C, and this circle is touching both the x and the y axis. Next, we'll consider a line such that it passes through the center. Now first we'll have to be a little careful how we sketch the line. It's given here, the equation of the line is 5x plus 12y equals to 1. We're going to rewrite this equation. So we'll keep 12y on the left hand side and transpose 5x to the right hand side to get negative 5x, and we have 1 added to it. We're going to divide both sides with 12. So we have y equals to negative 5 over 12 times x plus 1 over 12. So clearly, if we compare this particular equation with the slope-intercept form, which is y equals to mx plus c, the m is the slope. So here we are getting a negative slope, and we have the y-intercept with a value which is 1 over 12. That's a positive number. And we know that whenever we have a y-intercept that is positive number, it means that the line is going to intercept the y-axis on the positive direction. Right? That is one. We have found it out, and the negative slope tells us that it's going to be slanted in the way it is shown here, because this angle theta, if we take the tangent of that gives us the slope of the line, and whenever we have a theta which is an obtuse angle, then the tangent of that obtuse angle is going to give us a negative value. So this is an approximate diagram, and here in this particular problem we are given with the equation of the line. So the line is 5x plus 12y equals to 1. Fine. Now our goal will be to first find out the coordinate of the center as well as the radius of the circle. Only then we'll be able to obtain the equation of the circle. So let's try to find out the coordinate of the center as well as the radius. For this, we're going to do a construction. So the construction being, from the center C, we're going to drop a perpendicular on the x-axis, and we're going to call it A. So CA is perpendicular to the x-axis. And then CA, let's write it down. CA is perpendicular to x-axis, and then we will drop another perpendicular from the center C to the y-axis, and we're going to call it CB. So CB is going to be perpendicular on the y-axis. Now, since the circle is touching the x-axis and the y-axis, this distance here, that's nothing but the radius of the circle. And CB, that's also going to be the radius of the circle. And this also gives us the coordinate of the center C. So for the coordinate of the center C, we need the x coordinate. So that's OA, the OA being R, and then we need the y coordinate, which is AC. So AC is going to be R as well. So now we have the center as well as the radius. So let's specify that. Let the radius be given by R, such that the radius are such that the coordinate of the center is given by R comma R. Fine. Now we have defined the coordinate of the center as well as the radius of the circle. Now since this particular point lies on the line 5x plus 12y equals to 1, this particular point is going to satisfy the equation of line. So let's write it down. Since C, which is R comma R, this point lie on the line 5x plus 12y equals to 1, this immediately tells us that we have 5 times R plus 12 times R equals to 1. All we have done is replace the value of x with R and the value of y with R as well. So solving this, we get 5R plus 12R, so that's going to be 17R. This is equals to 1. So solving for the radius, we get 1 over 17. Now we have obtained the radius. So our radius comes out to be equals to 1 over 17, and this is also the radius 1 over 17, and we have the coordinate of the center. So that's 1 over 17 comma 1 over 17. So now that we have the center of the circle as well as the radius of the circle, we are ready to find out this equation. For this, we're going to take the help of the standard form of a circle. So let's first specify what we mean by the standard form of a circle. So suppose we have a circle whose center has the coordinate h comma k and the radius is r, then the standard form of a circle is given by this particular equation: x minus h whole squared plus y minus k whole squared equals to r squared. Now in a case, we have defined the center of a circle, which is 1 over 17 comma 1 over 17, and then we also have obtained a radius, which is 1 over 17. So let's use this. So our center h comma k came out to be the coordinate 1 over 17 comma 1 over 17, and that gives us the value of h. So h comes out to be 1 over 17 and k comes out to be 1 over 17 as well. Also, we have found out the radius r, which is 1 over 17. We're going to replace this value into the standard equation. So we get x minus 1 over 17 whole squared plus y minus 1 over 17 whole squared equals to the square of the radius 1 over 17 whole squared. So this is going to be the standard equation of the circle, and if you want, you can also simplify this, but I'm going to leave the answer in this particular fashion.